All right, girls and boys. Nah, it was like the queue was empty, and I was like, okay, let's keep it rolling. Anyway, good evening, good day for all the others. Yes, Psycho, yeah, welcome. And we have a pretty full moon here. It's literally a real full moon. It's already midnight here in Austria, Europe. Welcome, Tanner. Welcome, Matt. Okay, let's give it up to Matt and continuing last week's session about programming, and we had some homework for him. What's about that?
Okay. Well, welcome, Tanner. How are you doing? So he said he's doing awesome. He's coming right up. So yeah, last week, that was a brand new world for me personally. When Tanner steps in, we'll discuss that. And I did have a few questions about, the esoterica of cryptocurrency. What was interesting for me when talking to both Tanner and talking to Scarlett the other week was to go over what exactly their background is. And what I saw as a commonality, and also with the devil, is that they all had programming experience as kids, where their teachers very quickly were of no use to them, and they led the class. So I didn't have that experience at all. And so in learning to try to program my 99 bottles of beer on the wall, I found a lot of roadblocks. I did at least get the computer to respond, but anyway, I guess we're looking at when we discuss what the fuck is cryptocurrency is, well, let me put it this way. I have questions about what is going on in the state of the industry right now, where Litecoin Cash fits in, where Ring fits in, and we'll go from there. Since those listening in general wanted to take on cryptocurrency, please put them in right now as like questions or whatever it is that you wanted to see Tanner talk about. I feel like we have a rare and good opportunity here, and want to take full advantage of it. So hey, first off, dude. Tanner, there you are. How you doing?
Good, man. How are you?
I am good. I spent a few hours this morning getting not too far in my first foray into programming, but it opened up a lot of questions for me.
Dude, I realized only today that there was one thing I really should have explained. One little technique that we needed in order to be able to complete the homework. So I'd love to see the point at which you got. Do you have your Repl.it work to hand?
I do. Can I post it somewhere? I made a copy of it because I wasn't sure how to link to it.
Yeah, perfect.
Shall I post it in general? Yeah, that way everyone can mock me. Equal opportunity mocking here. That's as far as I got. Did that show up?
Okay. I see where you were going with this. Are you familiar with 99 bottles of beer?
Am I with the song?
Yeah,
all the way down to 1 from 99? Yes.
Okay, that's what the program was supposed to do. But okay. Well, we'll right. What we'll do is let me get a browser window and I'll start a screen share. Am I on? I need to enable Vox. Just one moment. Sorry, dude.
Oh yeah. So what I was going to say is my intention with the 99 bottles, where I just ran aground was my thought was, to essentially have an if-then function of if the number is greater than 2, to subtract 1, and then have variables for the song 99 bottles of beer on the wall.
Okay, that sounds like a really good strategy. That sounds like a really good strategy. Okay, one moment.
Just couldn't execute on it.
Well, let's see if we can fix that.
Very good. What
Okay,
I think is
I'm
immediately
go on.
Go ahead. I was just going to say what's immediately apparent to everyone is I just have zero experience in this realm, but I certainly enjoy learning, and I don't mind looking really stupid. So two pluses there, at least for participation.
Dude, I think that's essential in order to learn anything. You have to, you know,
Yes.
not mind how stupid you look at the start, but you don't look stupid at all by having pasted what you pasted. But what's more interesting to me, wait a second. I've broken it. Do I have a screen share? Can you see it?
You know, I bet we had to click on something by your name. There it is. You click on the live by your name, and then there's the screen share. Yes, we're good.
Awesome. Okay. Also, because I was slightly ambushed, I'm not screen recording this, so if nobody else is, then it's going to go. Okay, so we're just going to start a new Repl.it, Python as usual.
And I did save screenshots from last week.
Say again.
I saved screenshots from last week, and that's what I did was based on those screenshots. But
cool. That's still you shouldn't actually need screenshots because the whole thing is there, of course. Like
yes.
This is just like paste bin. These don't go away.
Very good.
These don't go away. And I added loads of notes, as you can see, so you can go back and use that as a reference.
Okay.
Yeah, it was actually
links to backups.
The one that's the very one. Yeah, I'll drop a link to that as well. Hey, Sunita. Hey, everybody on channel. Hopefully, we're not going to go too fast for people who missed the first episode last time. But to give a brief recap, we're gonna explain you a crypto from the ground up, and in order to do that, there's two things that we need to understand, which are quite sort of computer programming. One of them is hash functions, and the other is public key cryptography. So, as a side effect of that, I'm kind of teaching you, if not teaching you to be a programmer, then teaching you to think like a programmer and to be able to understand simple code. So where we're at the moment is last week we saw 3 fundamental truths of programming: variables, functions, and flow control. And
variables, functions, flow control.
Indeed. And this week we're starting by looking at Matt's homework, which was to write a program to output the lyrics of 99 bottles of beer. So, Matt, what was actually more interesting to me than the code that you pasted was your kind of description of like how to do it logically. Just read that out to me again. I'm just going to type as you read.
Yeah, so I'd actually written this out, but I just didn't know how to execute it. To have the thing ask how many bottles of beer on your wall, and it would accept no input but 90. And then, I thought, if I could do it, you could put any number in, and it would just count down from that number.
Okay,
and
I like that strategy. And it's 99 bottles of beer, so we're only ever going to want to count down from 99.
And yet there is a part of you sometimes you're like, you know what, I can count down from 20 bottles. Like I've got the energy to do that. So I just wanted to offer that customization. That's where I was coming from.
That's excellent parameterization that you've attempted to build in. But okay, so go on. We have some number stored somewhere indicating the number of bottles of beer that are remaining on the wall.
And I wanted beer -1. And so each iteration of it was going to have beer -1. So print, I had bottle count, bottles of beer on the wall, bottle count, bottles of beer, take 1 down, pass it or them around, because I was going to add variables to allow to count down for more than just like, let's just bring a shelf off, right? 10 bottles down. So you don't have to count one by one.
Oh, wow. Okay. That's like ultra parameters. Okay. I love the way you're thinking, man. This is all great stuff. We'll start with the simple case. And then if you want to parameterize it, we can do it. But all right. So I'm just going to code what you said. So we have a variable that comes from somewhere, as you said, that's going to keep track of the number of bottles that are on the wall. So we'll just call it, we're going to start with it set at 99. And then the next thing you said, we're going to go, bottles -1. And while bottles bottles is more than one, we keep going. So, okay, that's good. We can make ourselves a while loop here.
Well, see, that was one thing I didn't realize when we were talking that I realized while doing my homework, that the while it's false allows you to do quite a bit while the variable is false until it's true, and then boom, it kicks something else.
Yeah,
I understood that then after working with it. So that was
cool.
great.
Absolutely. Yeah. And I mean, like what we did here with our while player has made same choice equals false in our get player choice function in our game last, that was kind of using like this Boolean flag that we were going to toggle at some point. And that's the only kind of like continuation criteria that we looked at for the while loop. But indeed, oh no, it's not, because we did also here detecting whether someone's won or not. We said while one of these scores is less than 5. So, well, either of these scores is less than 5. So while player scores less than 5 and computer scores less than 5. So yeah, we can just do a really similar thing here. While bottles is bigger than 0, do some stuff, whoops. And then the last thing in our loop will be bottles equals bottles minus 1.
Interesting.
So let's
keep talking.
Let's just print output verse here. And all right, let's just run what we've got. What we hope to see is output verse here repeated 99 times, right? Okay. I mean, I'm not gonna count them, but that looks plausible. So all right.
Yes.
Let's crack on and just make it output the actual lyrics that we want.
Okay.
Okay, so already we actually have a problem. We know how to output some text, and we also, if you've played with it, I don't know if you have, but I think this is going to work fine if we just go print bottle. Yeah, okay, we can see a countdown.
Okay.
But what we wanted to be able to do is to be able to say, you know,
Yeah, that was the first thing I ran into. Is the first song of the lyric is a variable.
Exactly. So you know what we really want to be able to do is something just like that.
Yes.
Is that going to work? I don't think it is, and I'll show you for why. So okay. No, wait, hang on. I think I need to clear all this previous output. Yeah, that's it. It doesn't reset the window every time. Okay, yeah, here we go. Right.
That's a very familiar look to me. That's all I saw.
Okay, and these can be quite cryptic.
Yes.
The problem is these errors are really descriptive. They're just incredibly tough. So for the uninitiated, they can need a little bit of interpretation. So what this is saying is you can't use plus to join together an int and a struct. Huh? What does that mean? Well, basically that means bottles here is a variable that we're using to store numbers. And once you're using a variable to store numbers, it then gets a little bit weird when you want to kind of do an addition operation, a string, a series of text, and the computer doesn't know how to interpret that. Like if we if we actually put the letters 99 in here, then I think this will work. Yeah, I mean, obviously it's always going to say 99 is the right number. But you know, in that sense, if we use the plus something that and something else that's a string, Python's like, okay, you know, I can tell that what you're trying to do is join these strings together, but that's not a string, it's an actual number. Then we're going to hit that type error again, because it's like you want me to add a number to it. What the hell does that mean? So is use a little function called which takes a number and converts a string. We're just going to do inline like this. The thing we're going to pass to it, and this was the very thing that I said I owed you an apology for and confessed to at the start of this episode, whereby I hadn't shown you that last how to combine
string. What does the STR stands for? String.
Yeah, and so this is let's just break this down a bit. Before we do this print, let's make a new variables. We'll call it bottle as string. So we can see from this, like this is immediately obvious. We're declaring a new variable because it's on the left-hand side of an equals sign. because
Oh,
whatever
okay.
this str thing is has brackets and isn't like a conditional. It's not like a while or an if. We know that str
Yeah.
is a what? It's a
Dream.
function.
Okay.
Okay. So anywhere these arguments appear, anywhere arguments appear, sorry, brackets appear, and it's not a conditional, we know we're calling a function. Just like this is a call to the print function. This is a call to the str function. Str accepts one argument, which must be an integer, and it just returns a string. So we pass it bottles as a number, it returns bottles as a string, and we put it in here. And then I can use that variable, the string variable, whoops, on this line, and now it's going to be happy, I think.
So the string, when you stringify that variable, it's kind of like a gerund, right? You turn a noun into a verb, or a verb into a noun, and
you're
you
doing a
can
type
use it.
conversion. Yes,
Yeah.
and that's exactly what that's called, is a type conversion. So anytime we have a number and we need to suddenly treat it as though it was text, instead of doing we want to print it out or something, we don't want to do mathematical calculations on it, then the chances are we're going to need to convert it to a string explicitly using this little helper function.
So it's a type function, and that's the string.
Str is a type conversion function, yeah, and it's
Type
converting
conversion.
an integer to a string,
which is just straight up magic.
I mean, it's one of those handy little helpers, and this maybe isn't 100%. You know how we're always trying to think in terms of generalities, and I'm not teaching you Python, I'm teaching you programming. So we're sticking to stuff that you're going to find in every single language. Hey, I mean, some languages are less fussy about this stuff, okay? And some are actually even more fussy. But there's plenty of languages that would have let us do this print bottle plus bottles of beer on the wall and been intelligent enough to figure out, hey, if we're using this plus operator between a number and a string, the only sane thing to do is to treat the number as a string and kind of join them up like we want. But not Python, sadly.
Okay, that's fair.
So let's just clear the output and run this, and we'll see that now, okay, yeah, we have it counting down like we wanted and like we expect. Perfect. However, I just want to simplify this. There's no need to actually capture the output of this function into a variable. What we can do instead is just put the whole thing there, which means that now the argument that we're passing to print consists of bottles converted to a string plus another string. So print understands perfectly well that we're talking about strings at this point. So this looks a little weird, this kind of, hey, let's just call a function and use its return variable as part of an argument to another function. But it's something we end up using a lot, especially for these kind of little, type converter functions like this.
And so if I need to think about flow, right? Flow control.
Yeah.
We're starting out saying the computer bottles are 99.
Yeah.
And while the bottles are greater than 0, right? We're going to print 99 plus bottles of beer on the wall.
Yep.
Followed after turning bottles into bottles minus 1, go back to the beginning. And
then we're going to go back to the first line inside our while loop. Yeah. So it's not going to go all the way back to the beginning of the program because we don't want to reset bottles to 99. It's just going to loop over this one, this one, this one, this one, this one, until we loop around here and suddenly the condition is false because bottles is no longer bigger than 0, and at which point it terminates. So we can really easily finish off the homework by just doing
take one down,
take one down, take one down, pass it around. But hang on, I think this is gonna. First of all, we need some spacing because if the verses aren't separated, it's ugly. So what we'll do is just pass. Can we just do print like that and don't pass it an argument? Does that give us an extra line? I don't remember. I really don't know Python. Yeah, it does. Okay.
Now I noticed one thing. You take one down and pass it around. Yeah, but you have the same number of beer bottles.
Yeah. Okay. So what can we do?
So it says take one down, pass it around. Is that when you then enter bottles equals or bottles is bottles minus 1.
Hey, that's a good idea. Okay, so we're going to move that to there. That's actually a really elegant solution. Let's do that. Oh, I keep forgetting that you have to clear this thing before you run it again. Otherwise, it's confusing. Yeah, look at that. 99 bottles of beer or 99 bottles of beer. Take one down, pass around 98. That was a really, really nice solution. Okay, perfect. And it hasn't even added any code. We just rearranged the code a little bit, which is my favorite kind of optimization.
That is a very simple code.
So I think the only thing wrong with this song now is 1 bottles. Ooh, I don't know. I don't know about that. So what needs to change on the last verse? Is that the only thing? 1 bottle of beer on the wall, 1 bottle of beer. Take one down, pass it. Okay, I'll tell you what we'll do.
And then it really needs to be no bottles of beer on the wall. So you really have the lyric is different that last iteration. Singular, singular, plural.
All right, fine. So we'll do that one bit at a time. First, we'll make it understand that bottle is different to bottles, and then we'll do that no instead of 0. All right. So what we'll do then is let's have a new variable, and we'll call it bottle or bottles. Okay, let's say, right, if bottles is equal to 1, do you remember the double equals? Because
yes, that means actual equals.
That means comparison. Yeah, that means is equal to, as opposed to the assignment operator, which means set this value. All right, cool. So if bottles equals 1, we're going to, what are we doing? What did I just say? Bottle or bottles? Yeah, okay, we're going to set bottle or bottles to be bottle.
Bottle, yeah.
I can't type. I'm honestly, I've only had 1 beer. I'm not tipsy or anything. So it's not tipsy fingers this week. I noticed some sarcastic comments last week. Jeez, I mean, come on. Right. So if bottles is 1, we're going to set bottle or bottles to bottle. Otherwise, we're going to set bottle or bottles to bottles. Too many bottles. Right. So now look, instead of we're just going to go plus bottle or bottles plus beer on the wall.
Okay. Yeah.
You with me?
Yes, I am.
All right.
That's really cool.
Let's see. Okay, this is good. Apart from we need space in there.
Oh, so interesting. On the second iteration, it's 1 bottle of beer on the wall, but then on the last one, it goes back to 1 bottles of. So it did the bottle just on that.
So this is an artifact. This is an artifact of us updating the value of bottle.
Okay.
So maybe what we need to do is move this bit.
Or if there's a way to say 1 or fewer.
There is. Okay, no, that's good. Wait, we'll do it your way. Okay, what did you say? If 1 or fewer, well, you can also say that as if less than 2, can't you?
Oh, yes, true. Yeah.
However, that being said, there just for the sake of completeness, I'll show you. There is a way we can say if 1 or fewer, and that's if bottles is less than or equal to 1.
Oh, okay, that's how you do that. Okay.
Yeah. So this on its own is less than, but this here is less than or equal to 1. So that will still give us. Well, let's run it and see. I've lost track. Okay.
So interesting.
2 bottles. Take one down, pass it around. 1 bottle. 1 bottles. 1 bottles. No bottle. All right. I'll tell you what we're going to do.
So interesting.
We're going to do something a little different. Okay. For a start, this wasn't a valid thing to do because if we only actually want 1 because if it's none, then you've got no bottles. You haven't got no bottle.
That's true. That's true. Very true.
You might have no bottle, but that's a separate issue. So do you know what I'm going to do? First of all, I'm going to actually undo your clever optimization of, hey, let's update bottles right here. What I'm going to do, it's almost always convention to update one's counter the last thing in one's while loop. So I'm just going to obey that convention for now. But instead, consider this line here where we actually print the last number bottle of beer. What we can do is, if we, in our argument to str, why is my browser frozen? There we go. In our argument to str, we can pass bottles -1 right there and say, hey, that's what we want converted to a str, please. Then that's not changing the value of bottles at all, is it? Because nowhere are we saying bottles equals something. We're just saying, for the sake of this parameter to str, we want to use the value bottles -1.
Okay.
All right. So also, I realized there's another issue with what we've done, which is we're already talking about bottles up here. So check for bottle or bottles actually should go first.
Oh, yes.
All right, let's see if we're looking. So 11 bottles, 10 bottles. Okay, that all looks fine. 2 bottles, 2 bottles. Take one down, pass it around. 1 bottles. Oh no, 1 bottles, 1 bottles, no bottle. Okay, we clearly made a mess here. Oh, okay, yeah. Look, you never alerted me to the fact that we still got that text there. We're not using our variable. That was a deliberate error on my part to see if you were paying attention.
And you know, I lost it. I failed it. So really, rather than bottles, it needs to be bottle or bottles.
It is.
We've already addressed.
Yeah, absolutely. Okay. And we need that space as well. So let's just grab this whole chunk and paste it there. And again there, and get rid of the word bottles. All right. Okay.
Okay. Yeah.
Okay. I think
you would get rid of the 13 and 14. You delete those.
Say again.
So the 13, 14. Why are those staying where you already have that up above?
What? Why aren't? Sorry.
Oh, never mind. You know what? I had to sing the song to myself. I'm okay now.
Okay, that's no problem. All right, we're really close. We're really close. Bottles, bottles, bottle. 1 bottle, 1 bottle. Take it one down, pass it around. 0 bottle of beer on the wall. Okay, so you know what we're going to do just for the very last line, because you don't just want to correct it to bottles, but you also want to have it no. We're just going to go if bottles equals 0, do a thing, else do this thing, and the thing that we're going to do if it's 0 is
okay. Got it.
That's what I'm talking about, baby. All right, okay. I think this is ultimate success. 2 bottles of beer on the wall, 2 bottles of beer, take one down, pass it around. 1 bottles. This programming lark, it's not easy, is it, Matt?
No.
All right. So do you know what? We're going to leave that there. I'm going to paste this on Discord right now. And your supplementary homework is to fix the second to last verse so that it doesn't say 1 bottles of beer on the wall.
It's right there. So that's what you've just pasted there.
Yeah, and as I continue to update it, you'll see that, you know, it's if you refresh it now, it'll have those comments at the top. Which is why if you go back to sizzling specific backups, the very first one from last week, it's of a lot more use than it was because I've added all these notes at the top.
Yes. Good.
All right. Awesome, dude. Do you have any queries on just this little homework run through / recap that we've done?
So at this point, I tend to be an experiential learner, and so I have to, you know, go in and get my hands dirty and, you know, tinker around. I did have some questions in terms of just what your vision is for where we go from here. You know, what we as an audience need to learn to then go with you to, you know, figuring out hash functions.
Well, that's actually the very next thing is hash functions.
Okay.
Which I thought might be time for a musical interlude, and we could then move on to that. And that is the main thrust of tonight's session. it's probably, I think it's probably only going to take us about an hour to fully understand what function is, the finer details of them, what they're used for, and how we can use them in programs, which is exciting stuff. So I'm going to throw the mic over to Deceivil. Spin us a tune, but no grunge, man. We can't do grunge. We're programming here. We have to have something.
No, no, all good. I can sing along or something. No.
You can sing 99 bottles of beer, Deceivil, if you want.
No, I got something special for you.
All right, keep the tempo up.
And now.
There we go.
Yeah, I feel like I just learned something.
Sorry, my fingers are slow.
That's fair. You know, if you look at like thinking about programming and code, right? You know, you told Devil, I want something up tempo. Well, he had something up tempo, but it didn't start out up tempo. And so if you were a computer, you would have, you know, input error. This isn't right because it's slow.
Right.
It's not what I asked for. But it
Guys,
was what you asked for.
I had no idea that you want to make a break.
Right.
You just fall into me. I'm taking care for computers, and I was like, what?
Well, what I was going to say is there a computer code function for the computer code equivalent of, hey, dude, just chill a minute. It's going to get there.
Optimistic style programming. I might be able to think of some kind of analog. I'm not sure.
Okay, fair enough. It was just a little thought.
But if we need fuzziness, we can build in the fuzziness. Like, yes, the computer's only going to do what we explicitly tell it to do, but we certainly have ways of explicitly telling it to be fuzzy or to accept unexpected parameters. Certainly.
Okay, very good. Well, I'll let you go because you have this in mind. It was just I couldn't help but say it.
Oh, cool. No worries. Yeah. So we're going to talk about hash functions, and this is one of my kind of two prerequisites towards being able to talk about what it means to design a cryptocurrency. The other is public key cryptography, which we'll look at next time or maybe the time after. But one of those essential components is hash functions. So I tell you what, let's first of all make a new code listing. Oh yeah, and for anybody who's joined us for the first time, you can just go to Repl.it and click Start Coding in order to get a Python environment you can follow along. Follow along with series in, look at the code listings that I'm doing, and design and run your own code right here. There's nothing to install, no sign up needed. Just click the Start Coding thing at the top right. So here I've got a brand new listing. I'm going to make my text a bit bigger as well. All right, so hash functions. Like after last episode, you have a new context for the word function, right? So
yes, I do.
Function is something that we can define like this. My hash function. It's gonna accept one argument. It's gonna do some magic computation. Oops, don't spell correct me. Rude. And it's going to return some final value. All right, so in terms of the type of function that is, we can see a hash function accepts one argument and returns one output, which means that, you know, as a test driver for our function, we could go hash equals my hash function, whatever, and then we could print out the hash. For now, we're just going to return the input data. Okay, so just looking at this trivial program, we know that although our program counter ostensibly starts at line 1, it's going to skip over all this, right? Because this is just a function definition. We have to actually call it for the program counter to end up inside this thing. which eventually happens on line 5, which is do you remember what we call the first line that gets executed? The
I don't.
entry point.
Program's entry point. I won't miss that again.
Not a problem. So we're going to do our function declarations at the top, and then our actual code that's using those functions is going to come below. So let me just do this. Okay, so I've just set up a skeleton to be able to talk about a function that has one input and one output. These aren't completely alien. Like, as an example, let's say, how do I do sign in Python? Is it hidden in a math object? No. Is it a mere Google away? Just 1 second. Oh, okay. Yeah, apparently it is math.sign. Do I need to import? Yes, I do. All right, cool. All right, so I'm just giving a little more context for a function that has one input and gives us one output. Like the sign function is a classic example. If we pass it 123, that's probably going to be radians, not degrees, engineering fans. But we should be able to print x. Yeah, okay, yeah, that's certainly legit. It's in the range. I'm happy. That's all right. So if the sign function always gives us the sign of the value that we pass it, a hash function always gives us a hash of whatever we pass it. Now, what does that mean?
That was my question.
So a hash function takes completely arbitrary input data of any length and returns a fixed length identifying string. Rather than actually declaring our own hash function, what we're going to do is import hashlib and use a real hash function so that we can talk about these in a bit more detail. And the one that we're going to use is, unsurprisingly, SHA-256. Now, this is one of those things where I have to do not too much hand waving and saying, just kind of trust me on this for now, but a little bit of hand waving. I need to remember how to do this. Okay, hashlib, gonna go SHA-256. It would be really nice if we could just pass it a string like that, but for reasons we can't, and we need to do dot encode on the end of it. That's absolutely massively annoying because this is this extends to one of these fundamental truths that I'm always banging on about, right?
Yes,
so far we've got variables, we've got functions, we've got flow control. Those are 3 of them.
Yes.
There's only 5. Okay, you only need to learn a total of 5, and that is programming. You have those.
Amongst
you can
the variety to learn. It is only 5.
Yes, I mean there's there are concepts to learn, but there's only 5 of them, and then you understand all of computer programming. And the last 2 are arrays, which we'll get to really soon, and object. And this is objecty, and I'm just not willing to talk about objects right now. But if you're willing to accept that in order for us to call this massively handy SHA-256 function, which will give us a hash of whatever we want it to, that lives inside this hashlib object, we need to annoyingly put dot encode on the end of the string that we're passing.
And that's objectifying it, you're saying?
It's
you didn't want to talk about it.
It's actually, I don't want to talk about it. It's still, it's not objectifying it. It's leaving it as a string, but it's performing an encoding. But the way it's doing it is treating the string itself as an object. And that's just not something that I want to. Like, people say Python's wonderful pedagogically, but, what's wonderful for me is a language where I don't have to do any hand wave, because I can, by the time we encounter something, you already kind of understand it on first viewing.
Yes.
And that's why this particular line infuriates me, and will infuriate me further, because I have to take the result of all that and call dot hex something. Okay, I really don't know Python, do I? Hang on, I'm just quickly Googling. Python,
that's true, because the Python this reminds me of is that old Monty Python sketch with the Spanish Inquisition, right? Because it starts with one thing, and very quickly it's an array of various torture techniques,
Right.
which just feels really relatable right now.
Absolutely. Okay, yeah, it's hex digest. That's going to work fine, and that's going to give us a string. Right. I'm going to keep importing math just because I like seeing that sign there at the end. Right. Okay, go again. Okay, this is perfect. That's what I wanted to see. Now,
Ooh, wow.
what's this? All right.
Yeah.
So what we have here is a hash and also a sign, because we still have this. Let's actually.
Can I ask a really stupid question?
By all means.
So, yeah, hash then is not unique to cryptocurrency. Hash
No,
is something
it's
that
not.
existed before. Okay.
Yes, and we're going to
Did
look
not
at
know
we're going
that.
to look at and examine why it exists, what it is, and its application.
Very good. Okay.
Before
Zip math, I'm ready.
even thinking in a crypto context, like at the moment, this has
Yes.
nothing to do with crypto. It has a
Very
lot
good.
of cryptographical applications, but at the moment, all I'm interested in is the fact that we have a function called SHA-256. We can pass it a string, and we get back a hash. And a hash, as we can see, is like, well, it's a really long number. In fact, it's so long
Yes.
that you'll notice we're in hexadecimal here.
Oh,
So in fact, rather than being, you know, eight, however many billion, 5, so this whole thing is actually encoding a much larger number. And I'm not going to get into
so this
exactly.
isn't even as large as what we have.
No.
Okay.
Let's go.
Very good.
Let's have a look at it. So let's go to Wolfram Alpha, who are helpfully, now I can tell Wolfram Alpha that this is a hex value I'm talking about by putting 0x on the front of it. Oops. And then paste in the thing that I want, which is this number here. Okay, now put that into decimal for me, and we'll see how many digits is that? Well, I actually know how many digits it is. It should be 64 hex digits. But if we put it into decimal, dun, it's taking the Wolfram Alpha supercomputer a while to even. Wow. Okay, that's a really long number.
Oh my hell! My hell! 10
like
to the 76.
10 to the 76. All right, so 10 to the 76. That's that particular value. The range that we're playing in here is, you know, larger still. But that's the particular hash value that we got. Now, how does this input relate to this output? Like, what are we actually looking at here? What we're looking at is the result of an absolute mathematical torture side this SHA-256. There's some unique features of what's going on in there that give the function really useful properties. The first is it's deterministic, by which I mean, we've got the word whatever. You can see our hash starts 8.5, ends 8.1. Let me just run it. Okay, yeah, we get the same thing. However many times I run it, we're always going to get the same thing. It's completely deterministic. That's the first salient point.
Okay.
So the same fact, it's so important. I'm going to make a big comment here. Hashing 101. The same input data always gives the same hash. Okay? Some more properties of this are that however long our input data is, we're also going to end up with a fixed length hash. It's always going to be the same. It's 64 characters of hex, which can run to some very, very large decimal numbers indeed, as we've seen. But however much text we pass to the input, let's pass pages and pages of whatever, and we run it, and yeah, we're getting a different number each time. Of course, if we run it with the same data, we'll keep getting the same one, AD22, AD22. But this output result is always 64 bytes. Rather 64 digits. So then we just get rid of all those whatevers. And we're going to add a new rule here. The output data length is I can spell irrespective without a spell checker. Irrespective of the input data length. And in fact, the output.
The hash is that a function or just a variable?
Well, okay. So that's a very good question. This hash we're calculating a hash and storing it in a variable called hash. So what we're putting in our little box called hash is the results of a hashing function called SHA-256. So the three important parts of this line, and I want you to kind of ignore everything else on this line because it is just Python being a little bit arsy. The input data to the function, which is our string here, the function itself, SHA-256, and then what we do with the output of that function, which is just store it in a value that we're calling hash. This could be called anything. We could call it my hash. We just have to change that. Okay?
Yes.
All right, cool. All right, so right.
So it's a variable.
My hash is a variable, yes. But what we're putting in that variable is the result of the function.
Yeah, sure.
All right, nice. So that second rule that we just covered, the output data length is always going to be the same. It's irrespective of the input data length. But it's short. Like, it's short. I know that, in this case, because this is a trivial example, our text whatever is shorter than the output hash. But, the vast majority of random bits of data are going to be longer than this very short length thing here.
Yes.
So not only is it irrespective of the input length, but output data length is also, in quotes, short. And the final, and this is really things get really interesting for us, is let's just go back to having a large amount of data. So it's about a page of whatever's at this font size. And I'm going to run that, see what the hash is, okay? E158. In fact, let's copy this whole thing. And I'm just going to whack it in a... do I really need to right-click? That's annoying. I'm just going to stick that in a comment there for reference. Make it so it fits. Okay. Now, what do you suppose happens if we change this R here to an S? Like,
we'll get a different output.
Okay, but how different? This is a really interesting thing.
Yeah, I don't understand what encoding whatever does and why it turned out such a big number. But I would have to think, well, I don't have any educated response.
Well, I guess the intuition is almost that it's only going to maybe this will turn into a 5 at the end of the hash.
Yeah.
Because our input data is so close. We changed an R to an S. What harm can it do? Okay, well, let's run it. Whoa.
Totally different.
Whoa. Let's line those up. Let's just look at these together in comment.
Not even remotely the same.
I mean, there's no commonality there at all. There's no commonality. Now, do you know why they're called hash functions? Where does this term come from? And exactly where you might think. You can't put
I think
the potato together.
Yes.
Okay. Once it's gone through this soup, it's in a completely unrecognizable form. And it's so sensitive to initial conditions that any change anywhere, instead of doing whatever, let's see if we can just get away with an extra character on the end. That's, again,
not even the same.
All right, it starts with an E, but apart from that, it's radically different. So we can't add something, we can't change something. What about if we just change something right in the middle? Is that gonna give us any? Come on.
Same response would be my guess.
Yeah, exactly.
Not even the same.
Totally different hashes. Oops. Except unless, of course, I fail to copy. I think this mouse is getting a bit dodgy. Right. So our third very important thing is that any tiny trivial change to the input data gives entirely different output data. And in fact, I'm going to capitalize entirely because, I mean, it really is entirely. There's absolutely no way that if I had an amount of text and a hash, I could contrive some subtle way to change a bit of that text to come up with the same hash. And to attempt to find these hash collisions. This is where we kind of get into talking about the strength of a hashing function. Like, okay, how well is it actually mashing the potato? You know, are there any statistical attacks that we can try by changing tiny little bits millions of times over and analyzing the output? And people run these types of attacks. MD5 used to be a very popular hashing function, but fell by the wayside because it's these days pretty trivial to find a collision for a reasonably sized amount of input data in a few minutes. SHA-256, so far, it remains kind of protected from these attacks. Nobody has an effective statistical attack against it, which is just as well our mining would break on Litecoin Cash.
Yeah.
The final rule, which I think when you combine the fact that you're always getting out a much shorter amount of data than you put in, combined with the fact that any tiny trivial change to the input data gives entirely different output data. If you combine those together, the final thing that we need to understand about hashes is quite obvious, really. There is no way to go backwards. There's no way to derive any information about the input data from the output data. You can't put the potato back together. Are these concepts making sense, making some sense, making no sense?
So if I had to recapitulate what you have there, it's you give an input of any size, shape, or form, it's going to come out the same every time, but it will have been completely hashed. And once it's been completely hashed, there's absolutely no way to reason back to original. So it cannot be done.
Absolutely. That's absolutely it.
That's what you mean by breaking a function. Is you're saying had someone figured out how to reason backwards? MD5. Someone could reason backwards then from it.
Yeah, absolutely. Well, no, it was more that given a potato and a hash brown, like find another potato that can produce the same hash brown.
Oh, okay.
And this as an attack has application that we'll see in a moment when we look at like actual why, these are interesting, but why might we want to use them in the real world? But look, just to really hammer home what we're talking about, let's instead make a variable called potato, and that's going to represent our input, and what we're going to hash is the potato, and of course what we're going to come up with at the end is a hash brown. So once we've done this, we've taken a potato, we've passed it through the SHA-256 function, if you like, and that gives us a hash brown. There is no going back.
Yes.
There's no going back. Okay. So why is this interesting? Well, one reason it's very interesting is for something like detecting file duplicates. Say you have a 1 gigabyte video file, and somewhere on your drive there's another identical 1 gigabyte video file. And say somebody wants to write a program to help you identify and get rid of this situation of having duplicates where you're wasting 1 gig of disk space. You could find, you could compare every file on the system to every other file. Okay, these files, they look the same length. We could manually compare every single byte of them. Or we could pre-calculate a hash and store that with the file data sometime. And that means that to do a duplication check, all we need to do is compare, instead of comparing 1 gigabyte, compare, 6,428 bytes of hash to another one. So it's a really useful way of giving a unique identifier to a block of data in such a way, actually, that doesn't, give away any kind of the actual content of the original data, but it can be used as a very, very good integrity check.
Oh, yes. So you're comparing outputs, but it's keeping the original source safe.
Yeah, exactly. And in fact, if we have a look on the Litecoin Cash website here, this is made use of so that you can tell that our wallets are actually genuine. Okay, let's actually do that and see this working. Do you see how underneath each download link, I make it bigger because the text's really small. There's a SHA-256 output there.
Oh yes.
This is a little way that can I copy that? Come here. Yes, I've copied too much. I'll just get just the bit I want in my clipboard, which is actually I've got the one that starts DB9. Which is that? Where is it? Yeah, it's this one. Okay. Litecoin Cache core for Windows 64-bit. So this is a really good way that we can use hashes to prove to you that the random binary you've downloaded is actually the genuine Litecoin Cache wallet. And I will show you for how. I'm just going to stash that on my desktop for a moment. And I'm going to start a Linux session. Okay, I'm just going to change the screen that I'm sharing. Change window. I want that one, please. Okay, now we have Linux console. Can you see that? Okay.
Yes.
Okay.
Oh wow, that is tiny.
Can I?
Bell Carbine.
It's just it's a while since I've used the WC. How do I even? Oh God! Hang on. I'll tell you what we'll do. We'll cheat. Just give me a git bash instead. Yeah, that's a much better idea. Okay, I'm changing my screen again. Okay, it's still small, but it's a better console. Right, so that binary that I just downloaded is called Litecoin Cache, blah, 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 blah. Now, I can use the SHA-256 command in Linux, which, thanks for that. It's really helpful. Command not found. Thanks, git bash. All right, I'm going to have to use Ubuntu. I'm switching back to... All right, hang on. Let me just figure out how to get to... I just need to find this mount point. Where the bollocks is my drive?
But if I had to guess what we're going to see, that little code, that hash.
I wanted to show you the bloody correct thing because, yeah, the idea is... all right, well, I'm not going to persist with that because it's boring looking at a black screen. I'm going to switch you back to my Python window. I am frustrated. Yeah, it's that one, I think. Are we back?
Yes. Damn, there we are. Yep.
Okay. Yeah, my point was, this is another way in which it's useful because the same input data is always going to give exactly the same output hash. It gives us a way that we can prove to you that the binary is actually our official one. So, you know, if somebody had poisoned the wallet by embedding some malware in there, the setup would end up giving a totally different SHA-256 checksum. So any way, any occasion that you want to be able to uniquely tag a chunk of data, hashing is
yeah.
Whether it's to provide security for users by saying, hey, look, we can prove this hasn't been tampered with if you get the same hash now that we got days ago, or whether you want to use that for deduplication of files because the same input gives the same output, we can use hashes to see, oh, hey, these video files match. We could delete one of them and save the disk space.
So my sister's a journalist, and you know, one of the problems they worry about are these you know, these videos now that anyone could create, right? Where you could make a video of, let's see, me, you know, like raping a dog, but I didn't do it, but you're able to create that, right? This is a way to authenticate. Yeah,
you mean me on Twitch or what?
Moving on.
You know,
yeah,
it probably said something about me that was the example I had at hand. But
so if a journalist, it would give a journalist a really good way to be able to validate and authenticate that something hasn't been tampered with. So say a journalist captures some footage, takes that 5 minutes of footage, runs a hash function against the video file. They can then, at any point in the future, take any copy of that video that somebody's got, run the hash function against that copy. If that hash function's remotely different from the one that they got right after shooting it, the footage has definitely been modified.
Exactly. And as you say, it's literally one variable change. The whole thing is different.
And I'm talking about 1 byte in
Yep.
our input file might be 16 gigabytes. It doesn't matter.
Yes.
You change 1 byte, you're getting completely different hash.
That's brilliant. Okay. So
Let me
I see
show
it
you
from the
something
security statement.
really, really cool. This is we're going to look really quickly at a practical application of hashing, which is in use for password verification. So remember, there's no way you can put the potato back together, okay?
Yes.
This gives us conceivably a really secure way that we can authenticate users without us having to actually store their password anywhere. Because what we can do is compare a hash of their password with a hash of whatever they type in. So I'll show you what I mean. What we're going to do first of all, let's just say that our password is wow, top secret 007. Okay. So what we'll do is just get a SHA-256 hash for that. Now, let's say this person's just signed up. Somebody's just signed up for a website, okay? This might get a little tenuous, but bear with me. It's going to make sense.
Yes.
I've just signed up for a website, and I've picked this password. So behind the scenes, the website has done a hash of that password and come up with this. Now, at that point, the website does not store my password. The website, probably they're going to need to put my information into a database somewhere, right? So what?
Yes.
It's going to be a minimum, my email address and some representation of my password. But look, they're not going to put, hang on, I need to copy this into a text file. I'm going to lose it and forget and not be able to make my point. Because our security is so good that there's no way to get that password back from the hash, which makes this hash a much less sensitive thing to store in the database than the actual password itself.
Sorry. But
sorry, could somebody just confirm that I'm streaming, please, so I can get back to
you are streaming.
Cool. All right, perfect. So I'm going to rewind a couple of minutes because this is quite dense once you lose the flow. So we're looking at hashing password in order to authenticate against a hypothetical website, okay?
Yes.
So I've just, as part of the process of signing up for a website, I've entered this password, wow, top secret 007, and the website has generated this hash, which I'm just going to copy into a comment here. I keep forgetting copying hash. So what I was less sensitive thing to actually put in the database than my no way original password hash. That's last point has any knowledge of my password. Now let's just have a quick at how the authentication process might work. We're going to terminate it by a flag while you have entered correct. Do some stuff, and we'll start with that set to false, of course. This format is killing me deep.
Yeah, you know what? That's a really good idea. Let me ask you this, though, because to me, the obvious question is if there's such a safe way, in other words, to use addressing versus someone's actual private keys, why don't most authentication sources use that?
Oh, they do where possible.
I don't.
Guys, I'm sorry. This has been a horrible failure, but yeah, I don't think this format's really working anyway, because I appreciate that a couple of the folk here sort of weren't here for the first episode. We hardly had anybody there for the first episode, and if you miss the start, you're kind of, I think it's really hard to jump into subsequent episodes anyway. So I hereby abort this experimental Friday night series. It's not working for me, but I would very much like to cover this stuff. I'd very much like to cover this stuff in a format where it's just me and Matt on like a Skype screen share or something, and put that content on YouTube or something else, because I think the content is really good. And the idea is really good, and I do lots of episodes planned, taking us right up to fully understanding how crypto works. So we'll do that at some point, mate.
Yeah, as we kind of look at this going forward, we still have other members of the core team I would love to interview. With these, at what pace would you want to record these Sky type
I
lessons?
think we can discuss that, but it wouldn't necessarily have to be as frequently as weekly. But I mean, I'm certainly up for doing them weekly. But of course, without them going out live, then there's without the impetus, it can be hard to see these things through. A live deadline can be a really good thing. So, well, maybe switch to a different form of streaming. Like our Saturday night shows tend to work a lot better. So I'll maybe try using the same tech we use there.
Oh, good. So we probably have this one at YouTube anyway, and continuing also on YouTube for the LCC.
I don't think we need it. No, I think
YouTube channel.
No, this has been a failure. I'm sorry. I don't think we need this one on YouTube.
Well,
it's
kind of what we go back to at the beginning is that you can't learn anything if you're not, willing to look stupid. And, I still say this was a noble effort. And I gained something from it, which is I understand that a hash function is not unique to cryptocurrency. That is a complete revelation to me.
I would even put it on YouTube as the failure of entertaining you. No, just joking.
Well, so there's a book called Infinite Jest. It was written back in the 1990s. And it consisted as kind of a backstory in the novel. You had a whole series of what they called failed entertainments. But what's interesting about a failed entertainment is that as an art form, it's itself as interesting as what someone might call a successful entertainment, because there's always something
exactly because you also learn from some failure.
So we kind of come full circle with cryptocurrency. Some are going to make it, some aren't going to make it. And what I am greatly looking forward to as we kind of figure out this whole, what the fuck is crypto?
As stored in the database. So this is the hash of the user's password that we put in our database when they first signed up. And that's the only thing that we have to check their password by. So then we're going into one of our, by now, quite familiar while loops where we're just checking for a termination flag. And inside that loop, the first thing we're going to do is ask for a password and get one. And then we're going to calculate the hash of whatever they just entered. And then all we need to do to know if they entered the correct password is to compare those hashes. Isn't that
so? That's
beautiful?
Why the mining algorithm matters, right? So it's hashing it the same way, so that the same input gets hashed the same way every time. And in this case, it's the private key that's get hashed that puts in a public output.
Nope. And don't think in terms of, you are way off on that, but don't think in terms of crypto for this. Just accept it for kind of what it is at this point, which is a way of smashing a potato into a hash brown with those 4 important properties. You can't derive any information about the input. The output's always the same length. Any change to the input data changes the output, and the same input data always gives the same output. So,
and that was the one piece I hadn't understood, is that the same input always gives the same output.
Right. Yeah. And we'll, in fact, next session, the first thing that we'll pick up, if we do continue this in some way, shape, or form, and to be honest, if we start again in a different medium, we'll probably redo episodes 1 and 2 so that we can kind of have a really nice archive of it. But after where we are now, we'll be looking at some actual cryptographic examples of hashing. And in fact, the homework is to produce a little miner once we've learned about that stuff, a little toy miner right here in Repl.it. So that'll be fun. But for now, just run that program and verify that I'm going to paste the password in general. The actual password is nowhere in the listing. So this illustrates that the whole point of this, of course, is if this website's database gets compromised, you ideally don't want the hackers to know that your user's password was wow top secret 007 and his email was Tanner at Litecoin Kadosh, because then you have a password combination that it might be worth going and trying on another 100 websites. Okay. So this is a really good way of preventing that by only storing the hashes.
That's beautiful. Thank you. This is how the West was won. One step at a time.
Matt, as ever, it's been a privilege. Thank you for
It
hosting
has.
this evil. Sorry once again for technical issues. We are new at doing this. We'll find the right format.
Thank you for your time, Tanner. It's always fun, always interesting. I took a lot of notes. So yeah, if we were going to recreate it, I can. Well, you're the one driving this, so I can respond.
Yeah, cool. I mean, yeah, I think we could redo the last episode and this one in a more archive-friendly format. And yeah, that'll be groovy.
Awesome.
All
well,
right.
thank you. We can
Thank
just privately figure it out. Thank you, Devil.
Hit the gold finger.
Well done, guys. Great job again.
We'll do. Love you all.
Love you, boys and girl. I see you there.